Today we are discussing an important reaction, and that is benzoin condensation. The reaction involves condensation of two aldehyde molecule to produce a molecule of alpha hydroxy ketone the reaction is catalyzed by a nucleophile like cyanide ion, and the reaction is usually done in polar protic solvent like ethanol water. Now let's look at importance of individual components. First, cyanide ion. Cyanide ion can be sourced from salt like NaCN or KCN. One can use other ionic salt of cyanide ion. Cyanide ion can also be generated from HCN. When you are using HCN, then you need a base. The function of base is to abstract proton from HCN. So base can be OH minus. If one is using a base like OH minus, then care must be taken not to add excess of base, otherwise it will interfere in the reaction. So one will generate water and NaCN when you are using NaOH. If you use KOH, then you will use KCN. So cyanide ion can be generated from HCN using a base. Now if you are using excess of NaOH, you know NaOH produces OH minus. OH minus is a nucleophile. The reaction uses cyanide ion as nucleophile. So if both nucleophiles are present, then OH minus may compete with cyanide ion. The reaction is not catalyzed by OH minus because cyanide ion has its own advantages. Now what are the advantages of cyanide ion? Number one, it is a good nucleophile for the reaction. And number two, it is a good leaving group. Although you know OH minus is a stronger nucleophile, so it should attack where it should attack, but then it won't leave easily because OH minus is not a good leaving group. So cyanide ion has an advantage over OH minus that it is a good nucleophile and a good leaving group, but OH minus is a good nucleophile but not a good leaving group. So cyanide ion can catalyze the reaction, OH minus cannot catalyze the reaction. You know, a catalyst enters in the first step of the reaction and leaves after the reaction is complete or in the last step of the reaction. So cyanide ion may act as a catalyst in reaction like benzoin condensation. Now let's look at the mechanism of the reaction. So we can start with a aldehyde, and you have a cyanide ion. Cyanide ion will attack the carbonyl carbon. Why it will attack carbonyl carbon? Because carbonyl carbon is a electrophile and cyanide ion is a nucleophile. So this carbon is electron poor, so it may act as a electrophile. Why this carbon is not electron rich? Because electron from this carbon are taken away by this electronegative oxygen atom through inductive effect and through through resonance by delocalization. So, oxygen is electron rich and carbon is not. So, this carbon, since it is electron poor, it is not rich in electron density, it can be attacked by a electron rich species like cyanide ion. Now, this carbon is attacking carbonyl carbon, a carbon carbon bond is forming. The arrow is showing that this carbon is forming a bond with this carbon. Now, this carbon is already having 4 bonds, so one bond should break. So, this pi bond will break and its electron will go to the oxygen atom. This attack may lead to a intermediate, and you may call that intermediate as tetrahedral intermediate. Now, we are showing this step as reversible step. Why we are showing this as reversible step? Because this negative charge may form a pi bond again, and if this pi bond is forming, then cyanide may leave, because cyanide is a good leaving group. So, the step is reversible step. If cyanide ion leaves, we may get the reactant back. There is another thing that may happen. This oxygen may also take a proton. We are having a protic solvent like water. Right? We are having water in the solvent system. We are also having another protic solvent, that is ethanol. So, any of these species can give proton to oxygen. So, if this oxygen takes a proton, if this oxygen, this negative charge takes a proton, we may generate a OH minus, which is a stronger base. We may generate a protonated tetrahedral intermediate and a OH minus. OH minus can take this proton, or OH minus can take this proton. Both protons can be taken by OH minus. If this proton is abstracted by OH minus, then we may get this intermediate again. So, this step is also reversible step. Now, if OH minus takes this proton, we may generate negative charge on carbon. Why OH minus may take this proton? Because negative charge on this carbon may be stabilized by electron withdrawing cyanide group or by electron withdrawing OH group. So, both OH group may decrease the negative charge on this carbon if it is generated here. So, we may write a tetrahedral intermediate like this, C minus OH and Cn. See, this negative charge is stabilized by electronegative cyanide group, electron withdrawing cyanide group, or by electron withdrawing OH group. So, a reduced charge on carbon may be much more stable than having a carbon which is rich in electron density. Now, you have what else you will generate? You will generate a water molecule. See, water molecule is donating a proton in this step, and water molecule is taking the proton back. So, a protic solvent is very good solvent for this reaction. Now, there is another important thing, that if this carbon takes a proton from water, we may go back to this intermediate. So, this step is also reversible, because this intermediate, right, there is a possibility that this intermediate may go to this intermediate again. So, this step may also be written as a reversible step. Now, there is a negative charge here. This negative charge can also act as a nucleophile. See when this negative charge takes the proton, then it is acting as a base. When this negative charge attacks other species, then it may act as a nucleophile. So, we have a nucleophilic center here in the molecule. Now, you know that you have other aldehyde molecule also in the reaction, and this other aldehyde molecule has a carbonyl carbon that is electrophilic. So, that electrophilic carbon may be attacked by this nucleophile, that is carbon, and if this bond is forming, then one bond here must break, and the weakest bond here is pi bond between carbon and oxygen. So, it may break to produce a species like this. See there is a carbon carbon bond, and you have a oxygen negative charge, then hydrogen and a benzene ring. Now, see a negative charge is generated here. So, if this negative charge forms a pi bond again, then this will go away, this part will go away from, right. So, the reaction is reversible, this product can go back. So, this reaction step is also reversible, this step is also reversible. So, we are putting a reversibility sign here, right. Since a carbon carbon bond is breaking here, so we may show that the reaction is favorable in the forward direction and not that much favorable in the backward direction. Now, what happened here is that there is a hydrogen here, and this hydrogen is attached to a electronegative oxygen atom, and you look at this, that this hydrogen may interact with this oxygen, because you have almost like a 5-membered ring. See 1, 2, 3, 4, and now if this interaction takes place, it will be the 5th bond, and you know 5-membered ring are stable. So, this oxygen may abstract this hydrogen intramolecularly, right. So, when there is a possibility of formation of 5 or 6-membered ring, then intramolecular abstraction of hydrogen is possible. So, this oxygen may abstract this proton, and if this oxygen is forming a bond with this hydrogen, see this oxygen is having 2 electrons. So, it can make a bond with this hydrogen, and if this bond is forming, then these electrons can go to oxygen atom, these electrons are free, right. This OH bond has 2 electrons, both these electrons will go to the oxygen atom, will generate another intermediate like this. Now, so there is a forward reaction. Can this intermediate go back? There is some possibility that this intermediate may go back. And now, how we can decide whether it can go back? Now, think about this oxygen atom. This oxygen atom has negative charge, and next to this oxygen atom you have carbon, hydrogen, benzene ring, and then another carbon, right. So, no other electronegative atom is attached to this oxygen. So, you have a high amount of electron density on this oxygen atom. So, this may not be that much stable, high amount of electron density on atoms are not that stable. If you look at this intermediate, this see oxygen has a negative charge, and then it is connected to carbon, and this carbon is connected to a benzene ring, cyanide ion, and then you have a carbon. See cyanide ion is electron withdrawing group, and this cyanide is present in the vicinity of oxygen, it will withdraw electron density from oxygen atom. So, this cyanide ion may stabilize negative charge on oxygen by reducing its electron density, right. So, this intermediate is much more stable than this intermediate. So, what is the driving force for proton abstraction? That this intermediate is going towards more stable species, right. So, this reaction, this step is more favorable towards towards forward direction than towards backward direction. And now, what happen is that this negative charge may form a pi bond, and if this pi bond is forming, then cyanide ion may leave. See this, these two electrons will go to cyanide ion. See, cyanide ion may leave in the last step. So, this step is not that much reversible, because first thing is cyanide ion is highly stable, and then you are having a species where you have a carbonyl group, and that carbonyl group is connected to another carbon, that will create a steric hindrance. So, you will generate a cyanide ion here in the last step. See, cyanide ion is entering in the first step and it is leaving in the last step. So, cyanide ion is acting as a catalyst. Generally, catalysts are not consumed in the reaction. Now, there are few important things about this reaction. One is, if you look at this first step, in the first step the carbon atom, this carbon atom is attacked by nucleophile cyanide ion, right. So, see, there are, if you look at benzene ring, you do not have any electron donating or electron withdrawing group. So, the cyanide ion is a good enough nucleophile to attack the carbonyl carbon. If you attach a electron donating group here at the para position, it will supply electron density to carbonyl carbon, making it electron rich. A electron rich carbon is not a good electrophile. So, it may not be attacked by a cyanide ion. So, if you attach electron donating group at the para position, first step may be retarded, because carbon will become, carbonyl carbon may become a weaker electrophile. If you attach electron donating group at ortho position, you will have additional factor of steric hindrance. The steric hindrance may be applicable at this position in the first step, it may also be applicable in this condensation step. So, electron donating group at ortho and para positions are not good for the reaction, right. Electron donating group at ortho or para positions are going to retard the first step by making aldehyde a less reactive compound, and then ortho, if you place a group at ortho position, steric hindrance may come into picture in this step. If you attach a electron withdrawing group, if you attach a electron withdrawing group at this step at para position or ortho position, electron withdrawing group may make carbonyl carbon a very good electrophile, a strong electrophile. So, first step may be facilitated by electron withdrawing group at ortho or para position, but as soon as this negative charge is generated, it may not react. Why? Because this carbon has to attack the carbonyl carbon, and if negative charge is, suppose a electron withdrawing group is present here, then it will withdraw, this electron withdrawing group will withdraw electron density from this carbon through resonance and through inductive effect. Now, if electron density is not present on this carbon, it may not attack the carbonyl carbon. So, electron withdrawing group will make this carbon a weaker nucleophile. A weaker nucleophile may not attack the carbonyl carbon. So, benzaldehyde type compound are good substrate for this reaction. Cyanide ion is a good nucleophile for this reaction. Other nucleophiles are also employed, but generally benzoin condensation is known with cyanide ion as a catalyst. So, this ends the today's topic. Hopefully, you may like it. If you have any question, you may write as comment. Thank you.